For chapter 6, topic is reaction of alpha beta hydrogen, Aldol and Claisen condensation. For this topic is a very important because I want to focus on Aldol and Claisen of reaction and also the mechanism involved for both of the reaction. So here is the subtopic for the reaction of alpha beta hydrogen. We learn about the acidity of alpha beta hydrogen. Next, about the alkylation and halogenation reaction. So aldol condensation, Claisen condensation, and lastly acetoacetic ester and malonic ester synthesis. So here is lesson plan from this chapter, and the introduction for this chapter. There are four types of carbonyl reaction. So there are nucleophilic addition, we learn from the chapter 2, alpha substitution from chapter 6. Okay, for carbonyl condensation also from this chapter, and nucleophilic acid substitution we learn from the previous chapter, is chapter 5. So what is the alpha substitution? So this alpha substitution is mean by substitute of one of the hydrogen attached to the alpha carbon by some other group. Okay, we want to substitute one hydrogen attached on the alpha carbon by some of other group. Okay, the keywords here is carbonyl compound convert into enolate ion or enol tautomer. Okay, the first step, carbonyl compound, we want to convert first into enolate ion or enol tautomer. So this intermediate enolate ion or enol tautomer, loss of hydrogen atom on the alpha position and become nucleophile. So once this enolate ion or enol tautomer become nucleophilic, so will attack on the electrophile, so complete for the substitution. Okay, this is step which is same like the previous chapter about the substitution mechanism and acid substitution. Okay, so example of the reaction involved for the alpha substitution, there are two, halogenation and alkylation. Okay, this is a general mechanism for alpha substitution. Okay, we can see here, this is C double bond O. Okay, to designated this as a alpha carbon must be next to the C double bond O. So base, which is a negative charge, will abstract this hydrogen. So this one carbon become enolate ion, C minus. So this phase we call as a nucleophile. Okay, so this nucleophile will attack the electrophile and remain on the electrophile. So what is the carbonyl condensation? Okay, carbonyl condensation involve alpha substitution. Okay, whereby this electrophile is another carbonyl compound. So either the nucleophilic addition, okay, or go through with the nucleophilic acid substitution. Okay, there are two types of nucleophilic. Okay, first, if the carbonyl condensation using the ketone and aldehyde, so the process protonation of the alkoxide will give the product nucleophilic addition. Okay, if ester, so loss of alkoxide, so will give the product in nucleophilic acid substitution. Okay, so there are two types of carbonyl condensation. First, Aldol condensation. Number 2 is Claisen condensation. Here, mechanism for the condensation aldehyde or ketone, or mechanism condensation with ester. Okay, the step first, this enolate, okay, C minus. Okay, because of this is nucleophilic, this one is electrophilic. Okay, C double bond O. So this nucleophile will attack another group, functional group for carbonyl. For this case is aldehyde. Okay, the concept for nucleophilic substitution is same. So nucleophile attack this C positive and this one pi bond will cleave. Okay, so what happened? The negative charge attached on this C atom and O minus. So what happened? Abstract proton from this one region and become addition product. Okay, OR minus is side product. For ester, the steps are same. So nucleophile attack on this electrophilic C double bond O, so pi bond will cleave. Okay, ester they have OR here, and then become the intermediate. Okay, for the above aldehyde or ketone, this one is they are intermediate, and this one for ester. Okay, so after attack, so nucleophilic will stay on the carbon. So end product will become C double bond O, and then this one is R group. Okay, how? Because O minus, okay, or minus elimination step to form the pi bond between C and O. So this one become left from the C. So that's why you get the substitution product. So there are two types of product. First, addition product if you are using the aldehyde or ketone. If this nucleophile attack any type of aldehyde or ketone, you can get addition product. While for the ester, nucleophile attack this one carbonyl from the ester, so form intermediate product, and last one end product substitution. So look at the acidity of the alpha hydrogen. Okay, hydrogen on carbon alpha to carbonyl. Okay, so alpha, how to design it for carbon alpha and beta. Okay, alpha carbon is mean the carbon is next to the C double bond O. Okay, so this one alpha hydrogen unusually acidic, very acidic. But for hydrogen on beta carbon are not acidic. This one is a very important part in to do for mechanism. Okay, first we learn about the acidity. Okay, so look at from this carbonyl. Okay, how to design it, this carbon as a alpha must be near to the C double bond O. So hydrogen attached on alpha carbon is a very acidic. Okay, so the reaction can occur for this one compared to beta. Beta hydrogen is not acidic. Acidic due to the two factors. First, carbonyl carbon, which have partial positive charge, attract electron from the alpha carbon. So it means C double bond O, we know that electronegativity. Okay, so this one become density positive, and this one is higher density of negative charge ion. So we call as the partial positive charge. Okay, attract electron from alpha carbon. Okay, because of this carbon is partial positive charge. Okay, so this one carbon from carbonyl will attract this electron from alpha carbon, polarize and weaken the CH. Okay, so resulting in ion, so form enolate anion. Okay, produce abstraction of alpha hydrogen is stabilized by resonance to the carbonyl. Okay, this is the most important part for the mechanism. You must understand. Okay, this one is base. Okay, negative charge will abstract this proton. Okay, once this proton left from this carbonyl group, so what happened? Electron move to the C. So C become less lone pair, so become negative charge. It form enolate anion. So for this intermediate, you must draw two structure A, structure B. Okay, we call resonance stabilized anion. Okay, C minus. So you must draw this structure C double bond O. So this one becomes C lone pair minus. Okay, from here you draw this one. Okay, so resonant it becomes C double bond C, so O minus. Okay, either you draw C minus or O minus. So O minus like same from the previous nucleophilic. Okay, CO, and this one become double bond. For this one, if this one is C minus, so C double bond O is remain. Okay, so plus side product. So again, the most important part for keto-enol tautomerism. Acidity of alpha hydrogen will undergo keto-enol tautomerism. So you need to draw two tautomer structure, keto tautomer and also enol tautomer. So what means by tautomerism? Okay, tautomer types of isomerization occurring by the migration of proton and movement of the double bond. Okay, so this is the meaning of the tautomerism: migration of proton and movement of double bond. If you can see here, movement of double bond. Okay, tautomer isomer that interconvert. So this one is the keyword for the keto tautomer and enol tautomer. Keto tautomer has a carbonyl C double bond O structure, but enol tautomer has vinyl alcohol structure. Okay, please start here. Keto tautomer, carbonyl C double bond O. Enol tautomer is mean OL, alcohol structure. So this one is keto-enol tautomerism. Acetaldehyde. Okay, this one is in keto form. Okay, O, C double bond O and H. Okay, sorry, for this one is acetaldehyde. This is in keto form because C double bond O. This one is enol form. Okay, C O H, and this one become C double bond C. Okay, we call as the keto enol. For acetone, okay, this one is keto tautomer, and this one is enol tautomer. Okay, for this one, cyclohexanone are also same. So this is keto tautomer, and this one is enol tautomer. Enol must be in form of alcohol. Keto is mean ketone, so in carbonyl form. Okay, what means by beta dicarbonyl compound? So primarily in the enol form. Okay, enol is more stable, conjugated pi system, and because of stabilization of the enol through hydrogen bonding. So this one is conjugated pi system. Okay, for example, this one is in keto form, but this keto form there are two of carbonyl. That's why we call as beta dicarbonyl. This one is beta dicarbonyl. Okay, so how they are enol in enol form? So primarily in the enol form. Enol is more stable. Okay, so enol is more stable compared to ketone because of conjugated pi system. What means by conjugated? Alternate. Okay, single bond, double bond, single bond, double bond. So if this one is mean by conjugated pi system. Okay, the electron is more stable. This structure is more stable compared to this one. Okay, so stabilization of the enol through hydrogen bonding. Okay, why? Because first conjugated pi system is more stable because of stabilization enol through hydrogen bonding. Okay, single bond, double bond, single bond, double bond, so it become hydrogen bond. So this one is the reason why this enol form more stable compared to keto form, because enol form can form hydrogen bonding. So mechanism of keto-enol tautomer. Okay, there are two: base catalyst and acid catalyst. Look at the base catalyst keto-enol tautomer. So presence of strong base ketone aldehyde act as a weak proton. Proton on the alpha carbon abstract to form resonance stabilized enolate ion. Okay, so equilibrium favors the keto form over the enolate ion. So look at the mechanism. Okay, this one is the mechanism for base catalyst ketoenol. Okay, this one is keto form. Okay, in keto form, so the reaction involve not the first step, deprotonation on carbon. Okay, deprotonation, not protonation. Deprotonation. So base, this one is base. Abstract this hydrogen. Okay, abstract. So it's become C minus. Okay, resonant in enolate ion C minus, this one, and the other one is CO minus. Okay, in these two structure, so two structure can attack for next step, because this one is nucleophilic, this become a nucleophile. Okay, for step 2, reprotonation on O. Okay, reprotonation O minus, abstract this proton, so it's become enol form and side product. Okay, this one is for base. First step, protonate this hydrogen. This one protonate this hydrogen, but we call as deprotonation on carbon. It means that remove hydrogen, detach hydrogen from carbon. That's why deprotonation on carbon. But this one, nucleophile, abstract this proton, okay, to become side product, water. So form intermediate enolate ion C minus or O minus. So this nucleophile, okay, abstract this proton. Okay, this become leaving group, so OH minus, and this one become alcohol product. Step 2. Okay, for base catalyst only 2 steps. But look at the acid catalyst. Okay, so here is the step for acid catalyst. Step 1, protonation on O. Okay, protonation on O, so it means this one lone pair. Okay, abstract this proton. Okay, so abstract this proton to become protonated carbonyl, O positive, and this one is C positive. Next step, this lone pair will abstract this proton to become hydronium ion, and this one electron move to here to become a pi bond. Okay, so this one is enol form. Enol form or vinyl, we call it as vinyl alcohol because double bond and contain of OH. So this one is for your exercises. Okay, acetophenone.